When you see this thing, what do you think this is? If you thought this is a universal remote IR signal capturing device, then you'd be correct. Yeah, I know I need to work on the name, but basically what this thing does is it will capture IR signals from any remote and replay them. So you can use this thing to control any device that uses an old IR remote. And the cool thing is you can actually record multiple signals from multiple remotes, which means you can use your phone or a computer to control multiple devices. So I got the idea to make something like this because I was just way too lazy. You see, this is where I stick my AC remote when I'm going to bed. And when I'm near the table, I stick it under the table like this. So the issue is sometimes I forget that the remote is still near the table, and when I go to the bed and tuck myself in, then only I will realize that the remote is not there. So I had to get out of the bed, get the remote, then go back in. And yes, I know that I can just go and buy another remote and that will just solve all my issues, right? Well, yeah, that will actually solve my issues, but that's such a boring solution. So that's why I want to make something like this. Actually, if you think about it, it doesn't really make sense because the whole reason why I wanted to make something like this is because I was too lazy to get the remote from the table. But now I'm just making a complex solution for this simple problem instead of buying a remote. But yeah, that's me. Anyway, let's finally start this project. For this project, I will be using a D1 Mini, but you can actually use other modules as well. For example, an ESP32 will work probably better than this. If you don't have a breadboard like this, then just get one. It makes it so much easier to work with these things. And it doesn't have to be expensive, even my one is pretty cheap. Next, to capture the signals, I need to use an IR receiver module like this. Alright, so now we can test the signal capturing part. Download and open Arduino IDE. And from there, go to Tools, Manage Libraries. Search for IR Remote ESP8266 and click on Install. After installing it, go to Files, Examples, and then IR Remote ESP8266 and click on IR Receive Dump V2. This is an example code provided by the library that we just installed. With this code, you can actually read IR signals. Alright, so now we need to flash this code to our D1 Mini. First, click on this drop down and then connect your D1 to your computer using a USB cable. Then a new thing will appear right here. Click on it and then click on the upload button. Next, open the serial monitor by going to Tools and clicking on Serial Monitor. Basically, this is where you will see the output from the D1. Now, when we press a button on our remote, it should in theory show the signal in our serial monitor. These are the values of the signal that I just captured. If I use a different remote, then the output will be different. Here you can clearly see, okay, maybe not clearly, but you can see that the signals are different. So the protocol on the first signal is Samsung and the second one is good weather. Maybe there's a bad weather also, but for now this protocol is good weather. And the second signal has something called message description. That's because the second signal is actually from an air conditioner remote. Usually when an AC remote sends a signal, it will send with the full context or full state of the air conditioner. Alright, so now we can read the signal. So now we just need to play the signal and see if it works. We can replicate the signal using the raw data section. So I modified the code so that way we can play the signal using the raw data part. To transmit or play the signal, we need another module like this, which is called an IR transmitter. This is pretty much the same IR LED you see on TV remotes. From the new code, when we press P on the serial monitor, it will play the signal. When we look at the IR LED from a camera, we can actually see that it's playing some sort of a signal. But to make sure that it's the same signal that we recorded, we need to go near a device and see if it works. Alright, so here I changed the code again. So this time I just combined the previous two codes. So that way we can capture and replay at the same time. Here on the code, I made a struct to store the IR signal details. Previously, I used the raw data to replicate the signal, but this time I'm using the hex value. Unlike with the raw data, we can't use just the hex value to replicate the signal. We also need some other details as well. For example, we need the protocol. That's why I made a struct. And I switched to the hex value because as you can see, the raw data is pretty big. So if we try to store multiple signals on our D1, it will fill up the storage pretty quickly. So with this new code, we can press R on our keyboard to record the new IR signal, and we can press P to play the signal. Here when I press P, it replicated the signal. And also it's saying the protocol is unknown. I have no idea why that's happening, just ignore that for now. Next, I added another feature to this code. These D1 modules have a Wi-Fi chip. I thought I can use this, so I put a web server on this, so that way I can have a small user interface to control this thing. Previously, if we need to control this thing, we need to press P or R in our serial monitor. That is not really practical because you need a computer for that. So that's why I went with the web server approach. When we run this code, you will see an IP address on the serial monitor. We can use this on a browser to access our user interface. And this is the user interface. Yes, I'm fully aware that the user interface looks like shit, but that's not the point right now, because the point right now is to see if the functionality is working properly or not. Here you will see something new called the EEPROM usage. It's just showing the details of the EEPROM. That's the storage where I'm storing the IR signal details. These capture buttons and the replay buttons will replace the previous R and P inputs. Alright, so before I go any further, I need to talk about the signal issue on this. The signal strength on this thing is pretty weak. That's why in the earlier demo I had to get super close to my air conditioner for it to work. But obviously that's gonna be a problem for a remote, so I need to do something about it. This is the module that I used in this project, and for some reason the signal strength on this thing is very weak. So I tried using a transistor to boost the signal, and it did work, but it only worked once because the booster signal instantly killed the LED. So my backup plan was to use a small LED from a different remote like this. I thought since the LED is much more smaller, it will use less power, so it will be much more brighter compared to the previous LED. When checking from the camera, it did seem like the brightness is overall better than the previous one, but still it's not really good as the original remote of the air conditioner. Then I remembered I actually have some old security cameras with me. These old black and white security cameras uses a high-powered IR LED for nighttime videos. If you see a camera at night with a red light on it, then it's probably using a high-powered IR LED. Even though humans can't see infrared, cameras can easily see infrared light. That's why these old cameras use infrared LEDs for nighttime videos. So my plan was to use the camera IR LED with my project. Alright, so unlike before, this time the signal is way more powerful. I also used the transistor to boost the signal, so now the signal is more powerful even than the remote. Here you can clearly see that the camera IR LED is much more powerful and brighter than the original remote. Alright, so now all the hardware components are added. Since this looks like a huge mess, I will explain a little bit. This right here is the IR LED from the camera. This red thing is the transistor that I'm using to boost the signal. The red thing is actually the heat shrink tubing, the thing that's in front of it, that's the transistor. This is the IR signal capturing module. This black cylinder thing is a passive buzzer that I added. I put an LED right here with a resistor. This is for showing the Wi-Fi status. I actually could have used the LED on the D1 itself, but I kind of forgot, so I just kept the LED as it is. And this purple wire is for resetting Wi-Fi details. I didn't really have a switch with me at the moment, so I just kept it as a wire. Alright, finally we can put this mess in a box or in my case a bottle, and make it look nice. So the link to my code as well as the links to all the components that I used are all in the description. I will also add comments to my code, so that way you can easily understand what's going on and what can be changed. Once I put all the components inside of the bottle, it looks way more organized and compact, but as you can see, it's transparent, so I can see all the guts of this thing. And to be honest, this thing does not look like a remote at all. I'm pretty sure if someone else sees this thing, they're gonna think this is a bomb. So obviously we need to do something about it. First I tried wrapping it with just electrical tape. I mean, it covered it alright, but the thing is it looks absolutely shit. So I had to scratch that idea. I tried painting it, that didn't work. And then later I tried wrapping it with this foam sheet. And that definitely helped with the look. Okay, so I know that it still doesn't really look like a remote, but hey, at least it doesn't look like something that could explode. So that's a good thing. Alright, so I modified the code again. I will quickly explain what I did. The first obvious change, as you can see, is the user interface. I wouldn't say it's beautiful, but it's presentable, I guess. So the user interface is split into two parts. So this part contains all the buttons, and then there's a settings section. From the settings section, I can assign signals to buttons, and now I can also rename buttons as well. I also changed the storage from EEPROM to SPIFS storage. That's because the EEPROM is very limited, so you can't really store that much information on it, especially since I'm changing the button names and storing those things as well. So that's all for the changes in the user interface section. If I go to the code section, I added this new library called Wi-Fi Manager. So previously the Wi-Fi details, the SSID and the password, those things were hard-coded into the code, which is okay, it works, but the thing is, if you ever want to connect this thing to a different router, then you need to hard-code it again, which is not really practical. So thanks to Wi-Fi Manager, you can actually directly connect from your phone to the D1 and then assign the Wi-Fi details. That way you don't have to hard-code or modify the code in any way. Next, I added another library called Cute Buzzer Sounds. I think this is the most important library of this whole entire project. I could have just used simple beep sounds, but as the name on this library suggests, it will give cute buzzer sounds. When I press a button, there's no way for me to confirm if a signal is played or not. With the buzzer, however, I can add sound effects. So when I press the button, it will play the signal and it will also play a sound from the buzzer as well. That way for sure I can know if a signal is played or not. I also added other sound effects as well. For example, if the Wi-Fi is disconnected or connected, it will play a sound. And if I'm pressing on a button that doesn't have a signal, it will play an error sound. I added sound effects for pretty much all the actions, so that way there's an audible confirmation for every action. So as of right now, to access this user interface, I need to enter the IP address of this device, which is okay, but the thing is, it doesn't really look that nice. Instead of numbers, I want to give it a human readable name. For that, we can use something called multicast DNS. What that does is, it allows us to use a human readable name to access our user interface. So here I added another library for the multicast DNS thing, and here instead of the IP address, I can just type mightyremote.local and I can easily access the user interface. Now keep in mind, on some devices, especially on Android devices, MDNS might not be supported, so in that case you might have to use the IP address. But if you're using something like a Windows computer or maybe an iPhone, then it shouldn't be a problem. Also, there's something that I need to mention. Previously when I use raw data, I can use just that to replicate the signal. But since I moved to using the hex value, I need the protocol as well. Different signals will use different protocols, so we can't just use one protocol for everything. Here for example, the protocol is Coolix. And we can't send this using the send good weather or send Samsung protocols. I will add the protocol details for common stuff. For example, Panasonic, LG, Sony, Beko, Toshiba, what else? Anyway, I can't really think of all the names, but you get the point. I will add for common stuff, so they should work. But if there's a protocol that is not that common, then I will show you how to add that manually. So when we try to record a signal, it will also get printed into the serial monitor. And if we try to play that signal and we get this sound, that means the protocol is not supported. In that case, you need to manually add it, and this is how you do it. First, copy your signal and go to ChatGPT and paste it. You can use whatever AI tool you want. This is just to make it easier for us. Next, go to the code and copy the handle replay function. Paste that and say on top you have the signal and on the bottom you have the function. Modify the function to use the protocol from the signal. When you get the output, you can easily copy this and paste it, and it should in theory work. If you don't like to use AI tools like ChatGPT, or maybe it just doesn't work, then you can modify the code yourself. You can go to the documentation of the library that we are using. Type irremote ESP8266 and on top you should see the GitHub link. Scroll down to the protocol section and click here. This table right here shows all the protocols that are supported by this library. So you can just search for the protocol from here. So my AC brand is this one, Media. And as you can see, there are other brands as well, like Toshiba, there's Tokyo, Bosch, Beko, Airwell. So multiple brands are using the same protocol. You can just click on any of them to get a sample code. From here I can just search for send Coolix, and this right here is the example. So I can modify my code according to this one. So that's how you can add your own protocols. Now I will show you how you can actually connect this thing to a router. If it's not connected to any router, it will have its own access point. To access this, all you need to do is go to the Wi-Fi settings and search for Wi-Fi. From here, look for Mighty Remote AP and connect to it. If the D1 is already connected to a router, then you will not see this Mighty Remote AP access point. In that case, you can press the Wi-Fi reset button to reset the details. Once you connect to the Mighty Remote access point, open up a browser and type 192.168.4.1. Alright, so this is the Wi-Fi manager section. From here, you can click on the configure Wi-Fi section. From this section, you can add your Wi-Fi details such as the SSID and password and click save, and that's it. Once it's connected, you can access the user interface using the IP address or mightyremote.local. You can also create a shortcut to this on your home screen, so that way it will be easier to access this page. Alright, so with that, the project is pretty much done. Now this thing is designed to be kept in a corner somewhere, and I'm keeping it on top of my cupboard so that way the signal can reach all the devices without being blocked. So these are the most common buttons that I use in my AC remote. The nice thing about this project is that you can add multiple remotes. So now I can control pretty much everything that uses a remote with my phone. You also don't have to worry about losing your remote because your phone is your remote, so you can't really lose that thing. So you can always have your remote with you. So that's all I have to show in this video, and if you like this type of content that I do, then feel free to support this channel by subscribing or liking this video, because that would definitely help out a lot. This channel is still pretty small and starting out, and I'm pretty sure probably nobody is gonna watch this, but if you are watching to this point, then genuinely thank you for watching. So yeah, I'll see you with the next video.